Q5162. As airspeed decreases in level flight below that speed for maximum lift/drag ratio, total drag of an airplane. A. Decreases because of lower parasite drag. B. Increases because of increased induced drag. C. Increases because of increased parasite drag. The correct answer is B. As airspeed decreases in level flight below the speed for maximum lift/drag ratio, the total drag of an airplane increases because of increased induced drag. Induced drag is the component of drag that is primarily caused by the production of lift. It is inversely proportional to the square of the airspeed and directly proportional to the lift coefficient. At the speed for maximum lift/drag ratio, the aircraft is operating at an optimal balance between lift and drag, resulting in the most efficient flight. However, as the airspeed decreases below this optimum point, the angle of attack must be increased to maintain lift. Increasing the angle of attack to generate more lift also increases the lift-induced drag. This is because a higher angle of attack produces stronger vortices and greater pressure differences, which create additional drag. While parasite drag also contributes to the total drag, at lower airspeeds, the increase in induced drag dominates. The decrease in airspeed results in a significant increase in induced drag, outweighing any potential decrease in parasite drag. Therefore, the correct answer is that as airspeed decreases in level flight below the speed for maximum lift/drag ratio, the total drag of an airplane increases because of increased induced drag. 5220. When transitioning from straight and level flight to a constant airspeed, climb the angle of attack and lift. A. Are increased and remain at a higher lift-to-weight ratio to maintain the climb. B. Remain the same and maintain a steady-state lift-to-weight ratio during the climb. C. Are momentarily increased and lift returns to a steady state during the climb. The correct answer is C. When transitioning from straight and level flight to a constant airspeed climb, the angle of attack and lift is momentarily increased, but lift eventually returns to a steady state during the climb. During the transition to a climb, the pilot typically increases the angle of attack momentarily to generate additional lift. This increase in angle of attack helps the aircraft to overcome the increased drag and maintain or increase altitude. However, once the aircraft has established a steady climb, the angle of attack and lift will return to a more typical or steady state. This is because the aircraft needs to balance the lift and weight forces to maintain a constant climb rate. While the lift-to-weight ratio may be different during the climb compared to straight and level flight, the goal is to establish a new steady state where the lift generated by the wings is equal to the weight of the aircraft to maintain the desired climb rate. Therefore, the correct answer is that during the transition from straight and level flight to a constant airspeed climb, the angle of attack and lift are momentarily increased, but lift returns to a steady state during the climb. 5220-1. To hold an airplane in level flight at airspeeds from very slow to very fast, a pilot must coordinate thrust and A. Angle of incidence, B. Gross weight, C. Angle of attack. The correct answer is C. To hold an airplane in level flight at airspeeds from very slow to very fast, a pilot must coordinate thrust and angle of attack. Thrust is the force generated by the engines or propulsion system, and it is responsible for providing the necessary forward propulsion to counteract drag. The angle of attack refers to the angle between the chord line of the wing and the oncoming airflow. It determines the lift generated by the wings. To maintain level flight at different airspeeds, the pilot needs to adjust both thrust and angle of attack. When flying at very slow airspeeds, such as during takeoff or landing, the pilot needs to increase both thrust and angle of attack to generate sufficient lift to overcome the increased drag and maintain level flight. At higher airspeeds, the pilot may need to reduce the angle of attack while maintaining a suitable thrust level to balance the forces and keep the airplane level. By coordinating thrust and angle of attack, the pilot can adjust the lift and drag forces to hold the airplane in level flight at different airspeeds. Therefore, the correct answer is that to hold an airplane in level flight at airspeeds from very slow to very fast, a pilot must coordinate thrust and angle of attack. 5158. Lift on a wing is most properly defined as the A. Force acting perpendicular to the relative wind. B. Differential pressure acting perpendicular to the chord of the wing. C. Reduced pressure resulting from a laminar flow over the upper chamber of an airfoil, which acts perpendicular to the mean camber. The correct answer is A. Lift on a wing is most properly defined as the force acting perpendicular to the relative wind. When an airplane is in flight, the wing shape and angle of attack create a pressure difference between the upper and lower surfaces of the wing. This pressure difference, combined with the dynamic properties of the airflow around the wing, generates a lifting force. The relative wind is the airflow that the wing experiences as it moves through the air. Lift is the component of the aerodynamic forces that acts perpendicular to this relative wind. While differential pressure and laminar flow are factors that contribute to lift generation, the most fundamental and accurate definition of lift is the force acting perpendicular to the relative wind. Therefore, the correct answer is that lift on a wing is most properly defined as the force acting perpendicular to the relative wind. 5201. An aircraft wing is designed to produce lift resulting from a difference in the A. Negative air pressure below and a vacuum above the wing's surface. B. Vacuum below the wing's surface and greater air pressure above the wing's surface. C. Higher air pressure below the wing's surface and lower air pressure above the wing's surface. The correct answer is C. An aircraft wing is designed to produce lift resulting from a difference in air pressure between the upper and lower surfaces of the wing. According to Bernoulli's principle, as the airflow moves over the curved upper surface of the wing, it accelerates and creates a region of lower pressure. At the same time, the airflow passing beneath the flatter lower surface of the wing moves at a slower speed, creating a region of higher pressure. This difference in air pressure between the upper and lower surfaces of the wing creates an upward force known as lift. The higher air pressure below the wing pushes against the lower surface, while the lower air pressure above the wing pulls on the upper surface. The combination of these forces generates lift, allowing the aircraft to overcome gravity and stay airborne. Therefore, the correct answer is that an aircraft wing is designed to produce lift resulting from a higher air pressure below the wing's surface and lower air pressure above the wing's surface.